Welcome! Tonight, we are going to embark on a quiet journey through a landscape defined by its scarcity and its resilience. Close your eyes or let them rest on a soft point in the room. Imagine a vast open horizon where the sky seems to stretch further than anywhere else. This is the high desert of New Mexico, a place where the relationship between the land and water is a delicate, ancient dance. In this part of the world, water is more than a resource. It is a precious guest that visits only occasionally. To understand this land, we must first understand its thirst. New Mexico is officially the sixth driest state in the United States. While other regions might measure their rainfall in feet, here we measure it in careful inches. Average across the entire state, only about 13 inches of precipitation fall in a single year. To visualize that, imagine the height of a standard ruler. That is all the moisture the clouds provide to the thirsty earth over the course of 365 days. Some years bring more and many bring less, creating a rhythm of life that must adapt to the whims of the sky. There is a scientific reason for this profound stillness and dryness. Much of New Mexico sits at a high elevation, with vast plateaus and rugged mountain ranges reaching toward the stars. At these heights, the air is thin. Because the atmospheric pressure is lower, the air molecules are spread further apart, and this thin air simply lacks the capacity to hold on to moisture the way that heavy, dense air at sea level does. It is an environment where water evaporates quickly, vanishing back into the blue before it can even soak deep into the soil. The very breath of the atmosphere here is light and parched. As we begin this exploration, I invite you to settle deeper into your pillows. Take a slow, gentle breath. Feel the weight of your body relaxing into the bed. If you find this quiet space we're creating it together helpful for your rest, please feel free to subscribe to the channel or like the video. It is a gentle way to support these sleepy journeys while you drift off toward a peaceful night. But why does so little rain reach this high plateau in the first place? To find the answer, we have to look far to the west, beyond the borders of the state, toward the great oceans and the massive mountain walls that stand between the coast and the desert. The dryness here isn't an accident. It is the result of a grand atmospheric journey that strips the air of its water long before it ever reaches the Rio Grande Valley. It is a process that begins with the wind and the rising peaks of the Great Divide. Let your mind drift westward now, toward the vast expanse of the Pacific Ocean. Imagine a great, invisible river of air flowing from the sea, carrying heavy, wet clouds toward the land. This air is thick and saturated with moisture, a deep reservoir of water traveling through the sky. But as this air moves eastward, it encounters a colossal jagged wall, the Sierra Nevada mountains. As this moist air is pushed upward by the rising slopes, a quiet transformation begins. The higher the air travels, the colder the atmosphere becomes. Science shows us that cool air simply cannot hold as much water vapor as warm air. And so, as the air climbs toward the peaks, it is forced to release its heavy burden. The clouds pour rain and heavy snow onto the western or windward side of the mountains. This is why the coastal ranges are often covered in deep green forests and rushing streams. However, by the time the air reaches the very top of those peaks and begins its long descent toward the high plateaus of New Mexico, it has been stripped of almost all its water. It is now what scientists call sinker air. As it moves down the eastern or leeward side of the mountains, the air begins to compress. As it compresses, it naturally warms up. This warming process changes the character of the air entirely. It becomes like a dry sponge, eager to soak up any moisture it can find rather than letting it fall as rain. This powerful atmospheric process is known as the rain shadow effect. It is the architect of the arid conditions that define the Intermountain West. New Mexico sits nestled deep within this shadow, a land where the clouds have already left their moisture behind on the distant mountain crests. In the southern reaches of the state, there is a second guardian of this dryness known as the Mogollon Rim. This massive geological escarpment acts as a secondary barrier, capturing moisture that might attempt to drift up from the south and the Gulf of California. It stands as a silent sentry, ensuring that the southern deserts remain characterized by their vast, sun-drenched horizons. Because of these great mountain walls, the air that finally settles over the mesas, canyons, and valleys of New Mexico is exceptionally pure, light, and incredibly dry. When you step outside into this environment, you can feel the lack of humidity immediately. It is a crispness that makes the world feel clear and sharp. This dryness is not just a lack of water. It is a fundamental quality of the air that changes how we experience the heat, the cold, and the very light of the sun. It is a sensation that invites a deep, quiet breath as the parched air carries away the heaviness of the day and leaves the world feeling open and still. As you breathe in this light, crisp air, you might notice how different it feels against your skin compared to the heavy, damp air of a coastal city or a lush river valley. In many parts of New Mexico, the relative humidity, which is the measure of how much water vapor the air is actually holding, compared to the maximum amount it could hold at that temperature, frequently drops below 10%. This is an incredibly low number, representing air that is profoundly thirsty for moisture. This low humidity creates a unique sensation of comfort, even when the sun is bright and the temperature is high. Because the air is so dry, it acts almost like a vacuum for moisture. When your body produces even the smallest amount of sweat to stay cool, that moisture evaporates out at almost the very instant it reaches the surface of your skin. Science tells us that this process of evaporation consumes energy in the form of heat, which effectively cools your body with remarkable efficiency. This is the secret behind the common saying that it is a dry heat. In a more humid climate, the air is already saturated with water, leaving very little room for your sweat to evaporate, which can make the heat feel heavy and stifling. But here the dry air is a willing partner in keeping you comfortable, making a 90-degree afternoon feel surprisingly pleasant, especially if you find a patch of shade. However, this lack of moisture in the atmosphere has another profound effect on the daily rhythm of the high desert. Water vapor is a powerful natural insulator. It acts like a thermal blanket, wrapping the earth and holding on to the sun's warmth long after the day has ended. In places with high humidity, the nights stay warm because the air holds on to that energy. But in the high desert, without that watery blanket, The air loses its heat with startling speed as soon as the sun dips below the horizon. The warmth of the day radiates upward, escaping into the vast, clear cosmos, without anything to catch it or bounce it back toward the ground. Because of this rapid cooling, it is very common to experience dramatic temperature swings between the peak of the afternoon and the depth of the night. A difference of 30 to 40 degrees within a single 12-hour period is not just a rarity, it is a regular feature of the landscape. You might spend your afternoon in light, breathable clothing only to find yourself reaching for a thick wool blanket or a warm sweater as the stars begin to emerge. It is a cycle of expansion and contraction, a daily breath of heat and cold that defines the life of the desert. It is strange to think that this land, so defined now by its thirst and its thin, dry air, was once a completely different world. The silence of the mesas and the dry crackle of the brush hide a secret history. To understand the water that remains here today, hidden deep beneath the red rocks and the sandy basins, we must look back through the immense, stretching layers of time to an era when this arid plateau was buried under the weight of an ancient, shimmering sea. Imagine, if you can, the vast landscape of New Mexico, not as it is now, with its sun-baked mesas and dry arroyos, but as a deep blue world of water. 75 million years ago, during the late Cretaceous period, this state was almost entirely submerged. At that time, North America was divided into two distinct land masses by a colossal body of water known as the Western Interior Seaway. This was not a small lake or a temporary flood, but a massive inland sea that stretched all the way from the warm waters of the Gulf of Mexico to the icy reaches of the Arctic Ocean. For millions of years, the rhythm of life here was not the rustle of dry sagebrush in the wind, but the gentle sway of underwater currents and the slow drifting of sediment to the sea floor. It is a strange and beautiful contrast to think that the very places where dust now swirls in the heat were once home to prehistoric marine life. If you were to walk through the high desert today, perhaps near the San Juan Basin or the white sands of the south, you might still find the tangible proof of this watery past. Hikers and geologists frequently discover marine fossils embedded in the desert rock, spiraled shells of ammonites, ancient relatives of the nautilus, and the delicate imprints of prehistoric fish. These fossils are quiet reminders that the ground beneath your feet has a memory of the ocean, a memory that is written in the very stone of the cliffs. As the millions of years drifted by, the Earth's crust began to shift and rise. Slowly, the Western Interior Seaway began its long retreat, draining away and leaving the land exposed to the sun once more. But as the water departed, it left behind a profound legacy. The countless generations of marine life and the endless rain of silt and sand had compressed over eons into thick, heavy layers of limestone and sandstone. These ancient rock formations, stacked like the pages of a very old book, now form the literal foundation of the New Mexico landscape. You see them in the red-orange bands of the mesas and the towering walls of the canyons. These layers of stone are more than just geological history. They are the guardians of the state's most precious resource. Because limestone and sandstone are naturally porous, they act like massive, subterranean containers. The tiny spaces between the grains of sand and the microscopic cracks within the stone layers are capable of holding vast quantities of water. This ancient sea, by laying down these sedimentary beds millions of years ago, created the very vessels that now catch and store the groundwater we rely on today. This hidden water, cradled within the stone, is a direct link to a time when the desert was a sea. As we move forward in time, the earth began to change again, not just by the layering of stone, but by the very ground itself, beginning to pull apart. This movement created the dramatic structures that define the heart of the state today, shaping the way water moves and settles in the deep basins of the rift. This pulling of the Earth's crust would eventually create a new kind of container, one even deeper and more complex than the ancient seabeds. Imagine the Earth's crust not as a static, solid shell, but as something that can move and stretch over vast periods of time. Right through the heart of New Mexico, there is a profound geological feature known as the Rio Grande Rift. It is a place where the North American plate is literally pulling itself apart, a slow and steady expansion that has been occurring for nearly 30 million years. This isn't a sudden or violent movement, but a gradual widening, a deep breath taken by the continent itself. To understand how rare this feature is, consider that the Rio Grande Rift is one of only 5 major continental rifts on the entire planet, joining the ranks of the Great East African Rift and the Baikal Rift in Russia. It is a global rarity, a signature of the Earth's internal energy manifesting right beneath the high desert soil. As the crust stretched and thinned over these millions of years, the land in the center began to subside, dropping down like a heavy weight sinking into soft sand. This created a series of deep, elongated basins that run from the northern border down toward the south. But these basins did not remain empty voids. Instead, they became the ultimate collectors for the mountains. As the surrounding peaks eroded, they sent down thousands of feet of sediment, grains of sand, smooth river pebbles, and fine silts. This material filled the rift basins to incredible depths, sometimes reaching over 15,000 feet thick. Because this sediment is loose and grainy, it creates a massive volume of space. This porous filling acts like a giant subterranean sponge, quiet and dark, holding water in the tiny spaces between every grain of sand and every piece of gravel. This is the foundation of what we call the Albuquerque Basin Aquifer. It is a hidden reservoir of immense proportions, cradled within the rift's deep embrace, providing a life-sustaining source of water for the communities that have grown above it. The water here moves with an incredible slowness, filtering through the ancient sands, protected from the sun and the wind by the layers of earth above. It is a silent, steady presence, a legacy of the earth's movement and the slow accumulation of time. While the rift defines the central spine of the state, New Mexico's water story is written in many different ways across its varied landscape. As we move away from the deep basins of the central rift and travel toward the wide open horizons of the eastern plains, we encounter a different kind of ancient treasure, one that stretches far beyond the borders of the state itself, hidden beneath the grasslands. As we leave the deep vaulted basins of the Rio Grande Rift behind, the landscape begins to flatten and stretch. To the east, the rugged mountains give way to the high plains, where the sky seems to grow larger and the horizon pulls further away toward the edge of the world. Beneath this vast golden expanse lies one of the most significant water features on the North American continent, hidden entirely from view. The eastern third of New Mexico sits quietly atop the massive Ogallala aquifer. It is part of a sprawling underground sea of fresh water that spans 8 different states, reaching from South Dakota all the way down to the Llano Estacado. While the Rio Grande Rift holds water in deep, localized pockets, the Ogallala is a vast sheet of saturation, a remnant of a very different time in Earth's history. Scientists often refer to the water within the Ogallala as fossil water. This is because much of the moisture held in these rocks was trapped underground during the last ice age, roughly 10,000 to 25,000 years ago. Imagine the cool ancient rains and the runoff from melting glaciers of a prehistoric era, slowly seeping through the surface and finding a permanent home in the darkness. It is water from a world that no longer exists, preserved in the silence of the earth. Because this water was deposited during a much wetter and cooler epoch, it recharges at an incredibly slow pace in our modern arid climate. In many parts of eastern New Mexico, the aquifer recharges by less than an inch per year. It is a fine, precious gift from the deep past, a reservoir that is being used much faster than the occasional desert rain can ever hope to replenish it. This ancient water is not held in large open caverns, but rather in the tiny microscopic spaces between layers of sand, river-washed gravel, and fine silt. It is a saturated landscape beneath the soil, where every grain of sand is surrounded by a thin film of ice-age moisture. This hidden treasure is what allows the vast grasslands of the high plains to flourish under the intense summer sun. It supports the hardy shortgrass prairies and the agriculture that sustains the rural communities of the East. It is the silent engine of the plains, providing a steady source of life in a land where the surface often appears dry and unforgiving. But the story of New Mexico's water is not solely written in these deep, ancient layers buried beneath the sand. While the aquifers provide a steady, hidden foundation, the pulse of the state's rivers and the seasonal rhythm of its valleys depend on a much more visible and vertical source. As we turn our gaze back toward the west, toward the jagged blue silhouettes of the great northern ranges, we begin to see the true water towers of the desert. To understand how life persists in the high altitude heat, we must look upward to the peaks that touch the clouds and hold the promise of the coming spring. In the high desert, the mountains are more than just a majestic backdrop of granite and pine. They are the true water towers of the Southwest. While we often think of rain as the primary source of life, in New Mexico, nearly 3/4 of the usable surface water actually comes from melting snow. It is a quiet, vertical storage system that holds the state's future in a frozen, crystalline state. High above the valley floors, the Sangre de Cristos and San Juan Mountains act as natural high-altitude reservoirs. During the long, cold winter months, they gather layer upon layer of white powder, stacking the moisture high where it stays frozen and safe from the immediate heat of the sun. This snowpack is the lifeblood of the region, a massive bank account of water that the land will draw upon when the seasons begin to turn. Think of the snow as a beautiful, slow-release mechanism. If all the winter's moisture fell as rain at once, it would simply rush off the hard-baked earth in a series of fleeting floods, lost as quickly as it arrived. But because it falls as snow, it stays exactly where it landed. It waits. As the temperatures gradually climb in the spring and early summer, the snow begins to melt at a measured, rhythmic pace. This steady, gentle trickle feeds the high mountain streams, which join together to fill the larger rivers that sustain the valleys below. It is a process of patience, a seasonal gift that arrives exactly when the thirst of the land is at its greatest. To understand how much water is hidden within these white drifts, scientists rely on a sophisticated network known as SNOWTEL, short for snow telemetry. These remote stations are tucked away in the most rugged, silent parts of the mountains, far from any human footprint. Using specialized pressure sensors and scales, they measure the snow water equivalent, not just how deep the snow is, but exactly how much liquid water it will produce once it finally melts. These quiet sentinels beam their data to satellites, allowing us to peek into the future and understand how much water will flow through the irrigation ditches in the months to come. A deep, healthy snowpack provides more than just drinking water. It serves as a protective blanket for the entire ecosystem. By keeping the forest floor moist well into the late spring, it acts as a vital barrier against early season wildfires. The slow seepage of melting snow soaks deep into the soil and the organic matter of the forest floor, keeping the trees hydrated and the undergrowth lush during the driest months of May and June. It is a cool, damp insurance policy provided by the winter scale, ensuring that the transition into summer is as gentle as possible. Yet, in the thin, dry air of the high desert, not all of this frozen treasure finds its way into the rivers. There is a strange, almost magical phenomenon that occurs at these high altitudes, a process where the snow seems to vanish into thin air without ever becoming a liquid. As we linger here among the quiet, sun-drenched peaks, we begin to notice that the relationship between the snow and the parched atmosphere is more complex than it first appears, involving a subtle transition that bypasses the liquid state entirely. In the unique environment of the high desert, where the air is incredibly dry and the sun is remarkably strong, a fascinating scientific process takes place called sublimation. It is a quiet, almost invisible event where snow and ice transform directly into water vapor, bypassing the liquid state entirely. Imagine a drift of snow sitting on a high, silent ridge. Instead of melting into a puddle or a trickle of water, the molecules of ice absorb just enough energy from the sun to break free and float away into the atmosphere as a gas. It is as if the snow is simply exhaling back into the sky that created it, a ghostly transition that leaves no trace behind on the cold ground. Because of this, not every snowflake that falls on the Sangre de Cristos or the San Juan Mountains will eventually find its way into a stream. This disappearing act means that a significant portion of our winter moisture never actually touches the soil as liquid water. It is a reminder of how the thirst of the atmosphere is always present, even in the coldest months, and how the dry air is constantly reaching out to reclaim the moisture it lacks. This process is most active on those brilliant, crisp days when the high-altitude winds are brisk and the sky is a deep, cloudless blue. The intense ultraviolet rays of the high desert sun provide the necessary energy, while the dry, hungry air provides the space for that moisture to escape. The wind acts like a soft brush, sweeping those water molecules away as soon as they turn to vapor, making room for more to follow in a continuous, silent cycle. Scientific measurements suggest that in many years, as much as 15 to 20% of the total snowpack can be lost to the atmosphere through sublimation. When you look up at the white-capped peaks in the distance, it is humbling to realize that nearly 1/5 of that water supply will vanish into the blue before it can ever reach the thirsty roots of the trees or the banks of the rivers in the valleys below. This constant tug-of-war between the solid snow and the gaseous air is a defining characteristic of our high-altitude landscape. It reinforces the overall aridity of the region, ensuring that even when the mountains look heavy with winter's bounty, the land remains a desert at heart. The air is always maintaining its own balance, keeping the moisture levels delicate and precious. But while a portion is lost to the sky, the vast majority of that snow does eventually succumb to the warmth of the spring sun. It begins its long downward journey, gathering in small rills and icy creeks, gaining strength and volume as it descends from the granite peaks. This collective movement of water, born from the high-altitude snows, creates the lifeblood of the entire region. It flows into a legendary river that carves its way through the very center of the state, serving as the primary artery for every living thing in its path. As we follow the path of the melting snow, we find ourselves standing on the banks of the great river, the ancient and vital Rio Grande. The journey from the high, snowy peaks down to the valley floor is a slow and beautiful transformation. As the spring sun gains strength, those icy crystals that survive the dry winds of winter finally begin to melt, turning into cold, clear droplets. These droplets gather in the crevices of ancient rocks, trickling through alpine meadows and joining together to form small, icy rills. These rills soon become creeks, and those creeks eventually converge to form the headwaters of a legendary river. This is the Rio Grande, a name that simply translates to Great River. It is a title well earned, as it stands as the fourth longest river system in the entire United States, a massive waterway that defines the geography of the American Southwest. Its epic story begins in the rugged, pine-scented heart of the San Juan Mountains in southern Colorado. Here, the water is at its most pristine, born from the pure snowmelt of the high country. From these cold, high-altitude origins, the water embarks on a massive, winding journey, traveling roughly 1,900 miles. It carves its way through deep volcanic canyons, winds through wide, sandy basins, and eventually forms the long international border between Texas and Mexico before finally reaching its destination in the warm, salty waters of the Gulf of Mexico. It is a journey of incredible scale, crossing through vastly different ecosystems and climates. In the quiet stretches of New Mexico, where the river serves as the central artery of life, it has been known by many names throughout history. While we call it the Rio Grande today, it has been referred to as the Pueblo Colorado, in various historical contexts and simply the Great River by the many cultures who have called its banks home for thousands of years. To the people living in the high desert, it is more than just a body of water. It is a silver thread that stitches together the diverse landscapes of the state, from the northern mountains to the southern plains. It is the reason that civilizations have been able to thrive in such an arid environment for millennia. Because this river is so heavily dependent on the mountain snowpack, its rhythm is deeply seasonal and follows the heartbeat of the earth. It does not flow with a steady, unchanging pulse like the rivers of the humid east. Instead, it waits patiently for the spring thaw. As the temperatures rise and the days grow longer, the mountain snow begins to release its grip in earnest. This creates a predictable and vital surge of water that moves down the state. The river's flow usually reaches its peak in late May or early June. During these weeks, the riverbed is full, and the water is often cloudy with silt, carrying the nutrients of the mountains down into the valleys. This annual pulse is the true signal of life in the desert, providing the necessary moisture for the ancient cottonwood forests, known locally as the bosque, to drink deeply and turn a vibrant, lush green. However, as the Rio Grande continues its long trek southward, moving away from its cool mountain cradle and into the increasingly hot and arid stretches of the state, its character begins to undergo a subtle but significant change. In many parts of the world, rivers grow larger and more powerful as they move toward the sea, fed by constant rainfall and smaller tributaries that join them along the way. But here, in the high desert, the river faces a constant struggle against the very environment it seeks to sustain. The further it travels from its source, the more it must contend with the sun's intense heat and the porous, thirsty nature of the earth below. This shift in the river's journey marks the beginning of a fascinating geological phenomenon, where the water begins to interact with the landscape in a way that is often hidden from the naked eye, leading to a process that hydrologists call a losing river. In the quiet stretches of the high desert, the Rio Grande performs a disappearing act that is as subtle as it is vital to the ecosystem. While we often think of rivers as growing larger as they flow, fed by the land around them, the Rio Grande is what hydrologists call a losing stream in many of its sections. This means that instead of receiving water from the surrounding landscape, the river actually gives its water back to the earth. As the water moves over the sandy, porous riverbed, it slowly and steadily seeps downward, filtering through layers of silt and gravel into the hidden depths below. It is a gentle, invisible process, a quiet conversation between the surface and the deep, as the river replenishes the ancient aquifers that lie beneath the desert floor. This seepage ensures that even when the surface appears dry, life-sustaining moisture is being stored safely underground, protected from the heat of the sun. But the earth is not the only force reaching out for the river's bounty. The high desert sky, with its vast expanse and low humidity, is always hungry for moisture. High evaporation rates take a significant toll on the river's volume as it winds through the warmer southern reaches of the state. Nowhere is this more evident than at Elephant Butte Reservoir, the largest body of water in New Mexico. Because of its large surface area and the intensity of the New Mexico sun, the reservoir can lose several feet of water depth every single year to evaporation alone. It is as if the atmosphere itself is slowly drinking from the lake, a constant silent lifting of water vapor back into the blue. On a warm day, thousands of gallons of water rise invisibly into the air, thinning the river's flow before it can reach the fields and towns downstream. There are times, particularly during years of extended drought, when the demands of the earth and the sky become more than the river can provide. In these seasons, the Rio Grande may even dry up completely in certain reaches, leaving behind a winding ribbon of cracked mud and sun-bleached stones. To see a great riverbed empty of its water is a powerful sight, a reminder of the profound aridity of this landscape. The water does not truly vanish, of course. It has simply moved into the soil or back into the atmosphere, waiting for the cycle to begin again. These dry stretches are a natural, if difficult, part of the rhythm of the high desert, a period of rest and waiting for the next great pulse of moisture to arrive. As you reflect on this delicate balance of water and heat, take a moment to settle into the comfort of your surroundings. Feel the weight of your body supported by your bed, and let the tension leave your shoulders. Take a slow, deep breath in, and as you exhale, imagine the quiet stillness of the desert at dusk, when the heat begins to fade and the world finds its breath. The earth is patient, and the water is always moving in its own time, whether flowing through a channel or resting deep within the cool, dark ground. Just as the desert waits for the rain, you can allow yourself to wait for sleep, knowing that everything is in its proper place. Let your mind drift toward the horizon, where the distant mountains meet the darkening sky, and feel the peace that comes with the cooling of the day. As you settle deeper into this sense of quiet, take another slow, intentional breath. Feel the air moving in and out, cool and steady. Imagine the scent of the dry earth beneath the high desert sun, a warm, dusty fragrance that seems to be waiting. It is the smell of a landscape holding its breath, anticipating a subtle but profound change in the atmosphere. This change arrives every year in a predictable, rhythmic cycle known as the North American monsoon. While the word might evoke images of tropical forests, here in the high desert, the monsoon is a season of dramatic, fleeting beauty that typically begins in early July and lasts through the end of September. It is the desert's second spring, a time when the parched ground finally receives the moisture it has craved through the long, dry months of May and June. The mechanics of this season are driven by the power of the sun itself. As the vast stretches of desert land heat up during the peak of summer, the air above the ground rises, creating a large zone of low pressure. This atmospheric shift acts like a giant invisible lung, drawing in moist, humid air from the distant waters of the Gulf of Mexico and the Gulf of California. This seasonal reversal of wind patterns marks the official start of the monsoon. These moisture-laden breezes travel hundreds of miles, climbing over mountain ranges and crossing vast plateaus, bringing the heavy, humid promise of rain to the arid interior. You can often feel the change before you see it, a slight heaviness in the air, a softening of the sharp, dry heat, and a scent of dampness carried on a sudden cool gust of wind that breaks the afternoon stillness. For much of New Mexico, these few months are the most critical time of the year for the entire ecosystem. In many regions, the monsoon storms provide nearly half of the total annual rainfall in just a few short weeks. Without this seasonal pulse of water, the grasses would wither and the wildlife would struggle to find enough to drink before the winter. It is a sudden, intense gift that transforms the landscape with startling speed. Hillsides that looked dormant and brown just days before can suddenly erupt into vibrant shades of emerald green, and wild flowers begin to bloom in the shadows of the sagebrush, taking advantage of the fleeting moisture. One of the most striking characteristics of these monsoon storms is how incredibly localized they can be. In the high desert, rain is rarely a blanket that covers the whole world at once. Instead, it is a scattered collection of individual storm cells, each with its own personality. You might stand on a porch and watch a heavy, dark curtain of rain drenching a neighboring field just a mile away, while your own garden remains perfectly dry and bathed in warm, golden sunlight. These isolated pillars of rain move slowly across the plains, leaving behind dark streaks on the horizon and the sound of distant, rolling thunder. The desert becomes a complex mosaic of wet and dry, where the clouds seem to choose their paths with a quiet, wandering precision, touching one patch of earth while leaving another to wait for another day. These storms are not like the steady gray rains of more temperate climates. They are powerful, singular events that rise up quickly against the vastness of the deep blue sky. As the afternoon heat reaches its peak, the white puffy clouds begin to tour and swell, growing into massive vertical structures that dominate the landscape. They are beautiful to watch, slow-motion giants building upward into the cooler layers of the atmosphere. To truly appreciate the wonder of these desert storms, we must look closer at the unique physics of how they form, and the strange, beautiful way they interact with the very dry air that sits beneath them. As you watch these towering clouds, you might notice something peculiar about their shape. In the high desert, the base of a storm cloud, the dark flat bottom where the rain begins, is often located much higher in the sky than it would be in a more humid environment. Because the air near the ground is so incredibly dry, the rising moisture has to travel much higher into the atmosphere before it finally cools enough to condense into a cloud. This creates a vast space of warm, parched air between the bottom of the cloud and the floor of the desert. When the rain finally begins to fall from these high-altitude clouds, it must descend through thousands of feet of this hungry, dry air. This leads to a beautiful and strange phenomenon known as virga. Sometimes the air is so thirsty that it evaporates the raindrops before they can ever reach the earth. From a distance, virga looks like delicate gray curtains or soft, wispy streaks hanging suspended from the clouds. It is as if the sky is reaching down to touch the desert, but the dry atmosphere gently pulls the moisture back up, recycling it before it can moisten the sand. You might see these ghostly trails of rain drifting across the horizon, a visual reminder of the constant tug of war between the moisture in the clouds and the dryness of the desert floor. However, when a storm becomes powerful enough, the rain eventually wins that battle and finally makes its way to the parched ground below. But the desert earth is not always ready to receive it. After months of intense sun and heat, the soil can become incredibly hard and compact, almost like a baked ceramic plate. This sun-hardened crust combined with the lack of dense vegetation to slow the water down, means the soil cannot absorb the rain quickly enough. Instead of soaking in, the water begins to gather and flow across the surface of the land. In a matter of minutes, these small trickles find their way into the many dry creek beds that lace the New Mexico landscape known locally as arroyos. What was a dusty, silent trench just moments before can suddenly transform into a moving ribbon of water. These flash floods are a natural and necessary part of the desert's rhythm, carrying sediment and nutrients downstream to nourish distant valleys. The sound of a rushing arroyo is a deep, low rumble that vibrates through the ground, a powerful signal that the water has returned. It is a brief, intense event that passes as quickly as it arrived, leaving the desert changed and refreshed. As the storm begins to move on, leaving the arroyos to slowly quiet down and the clouds to break apart, a new sensation begins to fill the air. It is not something you see or hear, but something you feel deep in your senses. The first few heavy drops hitting the warm, dry earth release a scent that is unlike any other in the world. It is the signature fragrance of the high desert after a storm, a complex and ancient aroma that signals a profound shift in the environment. As the heavy, fat raindrops finally strike the sun-baked ground, a transformation occurs that is almost mystical in its intensity. You may have noticed it before, that deep, earthy, and strangely sweet fragrance that seems to rise from the very dust beneath your feet as the first moisture touches it. This scent has a unique power to calm the mind, a fragrance that feels as old as the earth itself. Scientists call this specific aroma petrichor. The word was coined in the 1960s, derived from the Greek petra, meaning cone and ichor, which in ancient mythology was the ethereal fluid that flowed in the veins of the gods. In the high desert of New Mexico, petrichor is more than just a smell. It is a profound signal of life returning to a thirsty land. But where does this scent truly come from? It isn't the water itself, but rather a complex chemical dance between the earth and the atmosphere. During the long dry periods that define the high desert, certain plants secrete a specific type of organic oil. This oil serves a vital biological purpose for the plant, acting as a chemical inhibitor that helps slow down seed germination and plant growth when water is scarce. It is the plant's way of ensuring it doesn't try to grow during a time when it cannot be supported. As these oils are produced, they don't simply vanish. They are absorbed by the clay-based soils and the porous surfaces of the surrounding rocks, where they sit dormant and invisible, waiting for the sky to open. When the rain finally arrives, the impact of the water droplets on the soil creates a tiny explosion of activity. As a raindrop hits a porous surface, it traps tiny bubbles of air against the earth. These bubbles then shoot upwards through the droplet and burst into a fine mist of aerosols, much like the fizz in a glass of sparkling water. This mist carries the concentrated plant oils into the wind. But there is another key ingredient in this fragrant recipe, a compound called geosmin. Geosmin is a substance produced by a type of soil-dwelling bacteria known as actinomycetes. These microscopic organisms are common in the earth and release geosmin as they die off or become active during the wetting process. It is the combination of these specialized plant oils and the bacterial geosmin that creates the unmistakable, heavy perfume of the desert rain. Perhaps the most incredible part of this story is our own human connection to it. Our species has a deep biological resonance with the scent of the wet earth. Human beings are remarkably sensitive to the scent of geosmin. In fact, our noses can detect it at concentrations as low as 5 parts per trillion. To help you visualize that incredible sensitivity, imagine a single drop of this compound diluted into the water of 20 Olympic-sized swimming pools. Even then, a human could still perceive its presence. Some evolutionary biologists believe this sensitivity is an ancient survival trait, a deep-seated instinct that allowed our ancestors to track water across vast, arid landscapes. When you breathe in that cool, refreshing scent after a New Mexico thunderstorm, you are experiencing a sensory bridge that spans thousands of years of human history, a quiet reminder of our enduring relationship with the natural world. As the scent of petrichor begins to drift through the cooling air and the desert turns crisp and clean, the landscape begins its slow, quiet recovery. The water that didn't wash away into the arroyos is now being eagerly claimed by the life that calls this high desert home. The plants that spent months waiting, secreting their oils and holding their breath, now begin the work of survival. But how do they manage to stay alive during those long, grueling months between the storms? To understand that, we must look closer at the ingenious ways these desert dwellers have redesigned themselves to become master containers of moisture. As the last echoes of the thunderstorm fade into the distance and the scent of the wet earth lingers, the desert plants begin their silent work of recovery. In this environment, water is more than just a resource. It is the currency of life, and every species has developed its own specialized bank to store it. One of the most iconic strategies is used by the succulents, a group of plants that have mastered the art of patience and preservation. Consider the prickly pear cactus, a common sight across the New Mexico mesas. To look at its flat green pads is to look at a living reservoir. These pads are thick and fleshy because they are filled with a specialized tissue designed to hold on to every possible drop of moisture. When the rare rains come, the shallow, wide-reaching roots of the cactus drink as much as they can, as quickly as they can, swelling the pads until they are firm and heavy. This stored water will be the plant's only lifeline during the long, parched months that inevitably follow. But storing water is only half of the battle. The other half is keeping it. Most plants in wetter climates breathe during the day, opening tiny pores called stomata to take in carbon dioxide for photosynthesis. In the high desert, however, this is a dangerous luxury. If a cactus opened its pores during the heat of the afternoon, the dry air would instantly suck the moisture right out of its body. To solve this, the cactus uses a remarkable process called CAM photosynthesis. Imagine the cactus as a patient observer of the sun's path. It keeps its pores tightly sealed throughout the heat of the day, effectively holding its breath to stay hydrated. Only when the sun is set and the air has finally cooled does the cactus begin to breathe. Under the cover of darkness, it opens its stomata to take in the carbon dioxide it needs, storing it as an acid until the morning light returns to power its growth. This nocturnal rhythm allows the plant to survive in conditions that would wither almost any other form of life. Even the sharp spines that cover the cactus have a gentle, protective purpose. You might think of them only as a defense against hungry animals, but they are actually highly specialized, modified leaves. Because they are so thin and hard, they do not lose water like a broad green leaf would. Instead, these thousands of tiny needles cast a complex network of miniature shadows over the plant's skin, lowering its surface temperature by several degrees. These spines also act as a physical barrier against the desert breeze. By breaking up the air flow right at the surface of the plant, they create a thin layer of still air, or a boundary layer, that prevents the wind from whisking away the moisture that remains. It is a quiet, structural engineering feat that allows the cactus to stand tall and vibrant even when the landscape around it seems to be shimmering with heat. While the cactus thrives by holding water deep within its fleshy tissues, other plants in the New Mexico landscape use a completely different method of endurance. Not every desert dweller is a succulent, yet some have managed to survive for thousands of years in the exact same spot, defying the heat through a combination of chemistry and resilience. One of the most remarkable of these is the creosote bush, a plant that doesn't just survive the drought, but seems to embody the very essence of the dry earth itself. If you have ever traveled through the southern parts of New Mexico, particularly through the vast stretches of the Chihuahuan Desert, you have likely seen the creosote bush. It is a humble olive green shrub, often standing no higher than a person, but do not let its modest appearance fool you. It is one of the most drought-tolerant plants in the entire world, a true master of the high desert's demanding conditions. While other plants might wilt and vanish during a prolonged dry spell, the creosote bush is a specialist in endurance. It is capable of surviving for several years without a single significant rainfall, entering a state of semi-dormancy, where it simply waits, patient and still, for the sky to change. To manage this incredible feat of survival, the creosote has developed a clever and beautiful defense. If you were to touch one of its small, pointed leaves, you would find they feel slightly sticky or even a bit stiff. This is because they are coated in a thick, waxy resin. This resin acts like a permanent seal, a protective varnish that locks moisture deep inside the plant's tissues. It prevents the thirsty desert air from stealing the plant's internal water, allowing the creosote to keep its leaves even when the soil around its roots has become bone dry. But there is something even more evocative about this resin than its ability to save water. This substance is responsible for one of the most iconic sensory experiences in the American Southwest. When the long-awaited monsoon rains finally arrive and the first droplets hit those waxy, resin-coated leaves, the water releases a powerful, earthy fragrance into the air. This is the distinct rain smell that many people associate with the desert. It is a sharp, clean, and medicinal scent, a mixture of camphor and fresh earth. To those who live in these arid lands, this fragrance is more than just a smell. It is a signal of relief, a reminder that the desert is finally drinking again. Perhaps most incredible is the creosote's profound sense of time. This plant does not rush. It grows slowly, adding only a tiny bit of height each decade. In some parts of the desert, these bushes grow in large, circular colonies known as clones. As the original plant in the center eventually dies away after centuries of life, new shoots grow from the edges of its ancient root system, slowly expanding outward in a ring. Some of these creosote clones are estimated to be over 11,000 years old. This means they have been standing in the same patch of earth since the end of the last ice age, quietly witnessing the world transform around them while they remain anchored in the sand. While the creosote bush survives by sealing itself off and waiting for the rain to come from the clouds, other plants in the New Mexico landscape take a much more active approach to finding moisture. Instead of relying on the unpredictable sky, they look downward, sending their roots on a long, determined journey into the dark depths of the earth. These plants do not wait for the rain. They go in search of the water that has been hidden away for ages. One of the most famous of these deep seekers is the mesquite tree, a plant that has mastered the art of reaching the unreachable. The mesquite tree is a master of endurance, a silent engineer of the desert floor. In the world of botany, these plants are known as phragophytes. It is a beautiful, evocative word derived from the Greek terms for well and plant. Essentially, the mesquite is a well drinker. While other plants might wait for the mercy of a passing cloud, the mesquite takes matters into its own hands, or rather, its own roots. Imagine the surface of the earth, hot and shimmering under the New Mexico sun. Now, imagine a single taproot, thin and determined, pushing its way down through layers of parched sand, heavy clay, and ancient rock. These roots do not stop until they find what they are looking for. In some cases, a mesquite's taproot can reach incredible depths of nearly 150 to 190 feet below the surface. To put that in perspective, that is the height of a 15-story building buried entirely underground, searching for a single drop of life. By reaching these immense depths, the mesquite is able to tap directly into the water table, the saturated zone where groundwater fills the spaces between rocks and sediment. This connection provides the tree with a steady, reliable source of moisture that is completely independent of the weather above. Because of this, the mesquite possesses a unique kind of visual magic. During the peak of a severe drought, when the grasses have turned brittle and yellow, and the earth has cracked open from the heat, the mesquite remains vibrantly, stubbornly green. Its lush, feathered leaves are a testament to the hidden river it has found deep in the dark, cool earth. The mesquite is not alone in this deep-reaching strategy. If you travel along the dry, sandy beds of arroyos, those desert watercourses that remain empty for most of the year, you will often see the graceful, slender branches of the desert willow. Like the mesquite, the desert willow is a phragophyte. It lines these dry wash beds because it knows that even when the surface is bone dry, water is often moving slowly, just a few feet beneath the sand. By anchoring themselves in these specific locations, these trees create ribbons of life across the landscape, providing shade and shelter for countless other species that depend on their presence. As the sun begins to set and the shadows of the mesquite and the desert willows stretch across the cooling sand, we can see that the desert is not a place of lack, but a place of profound ingenuity. The plants have found their ways to stay hydrated, whether by sealing themselves in wax or by drinking from wells deep in the earth. But the plants are not the only ones with a story of survival. In the quiet of the evening, as the air turns crisp and the sky begins to blush with the colors of twilight, the animals of the high desert begin to stir. Some of these creatures have developed even more radical ways to exist in a land without water, ways that do not involve drinking at all. As the orange glow of the horizon fades into a deep indigo blue, the high desert begins to breathe. The intense heat of the day recedes, and the first cool breezes of the night begin to whisper through the mesquite branches. It is in this quiet transition that one of the desert's most remarkable residents emerges from its burrow. It is small, with large, soulful eyes and powerful hind legs that give it its name, the kangaroo rat. But it is not its appearance that makes it a marvel of the high desert. It is its relationship with water. In a landscape where every drop is precious, the kangaroo rat has achieved the impossible. It can live its entire life without ever taking a single drink of water. While a human would only survive a few days in this environment without a source of hydration, this tiny creature never visits a spring, a puddle, or a stream. Instead, it has mastered the art of internal chemistry. The kangaroo rat gets all the moisture it needs from the very food it eats. Dry seeds collected from the desert floor. Through a complex metabolic process, its body breaks down the carbohydrates and fats in these seeds, releasing water as a byproduct. Every seed is a tiny, concentrated reservoir of life, providing just enough fluid to keep the little traveler moving through the starlit sands. To make this small amount of water last, the kangaroo rat's body is a masterpiece of conservation. Its kidneys are incredibly specialized, roughly 4 times more efficient at filtering waste and retaining water than our own. It produces almost no liquid waste, ensuring that every molecule of moisture stays within its system. This efficiency allows it to thrive in the driest corners of New Mexico, where other animals simply could not survive. The conservation continues even with every breath it takes. As the kangaroo rat exhales, its unique nasal passages act as a cooling system. These passages are lined with specialized membranes that capture the moisture from its warm breath before it can escape into the dry night air. This recycled water is then reabsorbed into the body, a closed-loop system of hydration that keeps the animal moist from the inside out. During the day, when the sun is at its most punishing, the kangaroo rat remains tucked away in its deep, cool burrow. It is strictly nocturnal, waiting for the safety of the shadows before venturing out. By staying underground during the heat of the day, it avoids the rapid dehydration that would occur in the sun, preserving its energy and its moisture for the peaceful, cool hours of the night. As the kangaroo rat skips across the moonlit dunes, we begin to see that survival in the high desert is a matter of patience and specialized timing. While some animals, like the rat, are active every night, others have found a way to wait even longer for the water they need. Deep beneath the surface of the dry earth, another creature is waiting, not for the moon, but for the sound of the rain. This is the world of the spadefoot toad, an animal that has mastered the art of the long sleep. Deep beneath the sun-baked crust of the desert floor, far below the reach of the parching winds, the spadefoot toad waits in a silence that lasts for most of the year. While the kangaroo rat moves through the night, this small, resilient amphibian is engaged in a different kind of survival. It spends up to 10 months of the year buried in the cool, dark earth, tucked away in a state of deep restorative rest. It does not need the moon or the stars. It only needs the patience to wait for the arrival of the great summer storms. To survive such a long period without access to surface water, the spadefoot toad has developed a remarkable physical defense. As it settles into the earth, it secretes a specialized mucus that gradually hardens around its body, forming a thin, protective cocoon. This translucent layer acts as a vital seal, locking in the toad's internal moisture and preventing the thirsty surrounding soil from drawing the water out through its skin. Inside this quiet, subterranean chamber, the toad's metabolism slows to a near halt, allowing it to survive on its stored energy for months on end. This state of dormant summer sleep is known as estivation. It is the desert's elegant answer to hibernation, a way for life to pause and wait when the environment becomes too dry and demanding to endure. The toad does not watch the sky or feel the shifting light. Instead, it listens with its entire body. It is uniquely sensitive to the low-frequency vibrations of heavy thunder rolling across the high plains. When the deep, resonant boom of a monsoon storm shakes the ground, the vibrations signal that the life-giving rains have finally arrived to soak the parched landscape. Once the heavy rains begin to saturate the soil, the spadefoot toad breaks free from its protective cocoon and begins the slow climb to the surface. It emerges into a world suddenly transformed by water, where temporary pools and shallow ponds have filled the hollows of the desert. There is a sense of quiet, purposeful urgency in these moments. Because these pools will not last long under the desert sun, the toad must move quickly. It has only a brief window of time, sometimes just a few days, to eat, find a mate, and lay its eggs before the water vanishes back into the earth and the air. As the tadpoles hatch and grow with incredible speed, they mirror the resilience of all life in this high-altitude landscape. They are a living testament to the idea that water is the fundamental rhythm that dictates the timing of every living thing. This deep ancestral understanding of water's scarcity and its power has shaped more than just the biology of the desert's animals. It has also shaped the very history of the people who have called this land home for centuries. Just as the toad waits for the rumble of the storm, the human inhabitants of New Mexico have spent generations learning how to catch, hold, and share every precious drop that falls from the sky, creating ancient systems of community and survival that are as enduring and patient as the desert itself. In the quiet valleys where the mountains meet the plains, the human response to the desert's thirst has taken the form of a living, breathing network of water. These are the acequias, ancient, gravity-fed irrigation ditches that have carved their way through the New Mexican soil for centuries. The word itself carries a soft, rhythmic quality, echoing the gentle flow of the water it describes. And a sequoia is more than just a simple channel in the earth. It is a community-operated system, a shared lifeline that connects neighbors to one another and to the land they tend. To walk beside an sequoia is to witness a tradition of stewardship that has remained largely unchanged since the first settlers arrived in these high deserts. The history of the sequoia is a tapestry of global knowledge, woven together by the unique needs of this arid landscape. While the system was brought to the Americas by Spanish settlers, its roots stretch back much further, drawing upon sophisticated Moorish engineering from North Africa and the deep local wisdom of indigenous Pueblo farmers who had already been irrigating the Rio Grande Valley for 1,000 years. These cultures understood that in a place where rain is a rare gift, water cannot be conquered. It must be carefully guided and shared. This blend of technologies, using the natural slope of the land to pull water from the rivers and into the fields, created a sustainable way of life that has endured through centuries of shifting climate. At the heart of every acequia is a person known as the mayor domo. The mayor domo is the elected water master, a role held with great respect and heavy responsibility. It is their task to oversee the health of the ditch, ensuring that the water is distributed fairly among all the families or parciantes who rely on it. During times of drought, when the river runs thin and the sun is relentless, the mayordomo manages the repartimiento, or the sharing of the water. They decide the schedule for when each gate is opened, making sure that even when the flow is low, every member of the community receives enough to sustain their crops. This ensures that no one person takes more than their fair share, fostering a sense of mutual reliance and peace that is essential for survival in the high desert. In the legal and cultural framework of the acequia, water is treated not as a private commodity to be bought and sold by the highest bidder, but as a communal resource, bien común. This philosophy stands in gentle contrast to many modern systems of ownership. Here, the right to water is tied directly to the land and the community's collective need. It is a philosophy of el agua es la vida. Water is life, and life belongs to everyone. This communal bond is reinforced every spring during the limpia, or the annual cleaning of the ditch. Neighbors gather with shovels and rakes to clear away the winter's silt and debris, working side by side in the crisp morning air to prepare the channel for the coming season's flow. The resilience of this system is truly remarkable. Many of the acequias still flowing today in northern New Mexico have been in continuous use for over 300 years. They have survived changes in governments, the drawing of new borders, and the arrival of the modern world, remaining as steady and reliable as the mountains that feed them. These ancient ditches are not merely relics of the past. They are functional, vital parts of the present, continuing to provide the moisture that allows small-scale agriculture to thrive in a landscape that might otherwise be too harsh to farm. As the water travels along these hand-dug paths, it does more than just irrigate the fields of heirloom corn, beans, and fruit trees. It begins to transform the very character of the land it passes through. Because the banks of an acequia are often made of porous, natural earth rather than concrete, the water doesn't just stay within the channel. It slowly seeps outward, soaking into the surrounding soil and creating narrow ribbons of vibrant green that cut across the dusty golden landscape. These linear oases become a sanctuary for life, fostering a delicate ecosystem that mirrors the lushness of the riverbanks themselves, even miles away from the river's main current. These ribbons of water, flowing quietly through the high desert valleys, do much more than just deliver moisture to a single field. They create what are known as linear oases, narrow, man-made riparian zones that mirror the lush environment of a natural riverbank. In a land defined by its dryness, these green corridors are a profound transformation of the landscape. Because most traditional acequias are hand-dug and left unlined with concrete, they remain porous and connected to the earth. This design allows a significant portion of the water to seep through the bottom and sides of the channel as it moves downstream. Far from being a loss, this seepage is a vital contribution to the valley's health, acting as a gentle, constant recharge for the local shallow aquifers. It keeps the underground water levels high enough to sustain life far beyond the reach of the water's surface. Imagine walking alongside one of these ditches on a warm afternoon. You would notice a distinct drop in temperature as you approach the water's edge. The air feels softer, carries a hint of damp earth, and is filled with the sound of rustling leaves. This is because the acequias support the growth of majestic Rio Grande cottonwoods and thickets of willow trees that simply would not survive in the open desert. The cottonwoods, with their deeply furrowed bark and shimmering heart-shaped leaves, provide a canopy of shade that protects the water from the direct heat of the sun, further reducing evaporation. In the autumn, these trees turn a brilliant glowing gold, marking the path of the water across the valley like a vein of precious metal. These corridors of vegetation serve another essential purpose. They are highways for wildlife. In a vast open landscape where cover can be sparse, the dense growth along the acequias provides a safe passage for animals moving through the territory. You might see a mule deer pausing for a drink in the early morning light, or hear the song of a red-winged blackbird nesting in the reeds. Migratory birds use these green lines as navigational landmarks, finding food and rest in the linear oases during their long journeys. This seepage and the life it supports is a fundamental part of the valley's ecosystem, proving that human intervention, when guided by a respect for natural cycles, can actually enhance the biodiversity of a region. This ancient understanding of how to live in harmony with a dry climate has left a lasting legacy on the culture of the Southwest. It teaches that beauty and life can thrive even with limited resources, provided those resources are managed with care and wisdom. As we move our gaze from these historic agricultural valleys toward the modern cities and suburban neighborhoods of the high desert, this philosophy of working with the environment rather than against it continues to evolve. In the urban landscape, this same respect for the desert's inherent character is expressed through a modern approach to gardening and land management. It is a transition from the lush, water-intensive landscapes of the past to a more thoughtful, resilient way of living known as xeriscaping. In the modern high desert, the way we design our gardens and public spaces has undergone a quiet revolution. The term xeriscape was specifically coined to describe this water-wise approach to landscaping, derived from the Greek word xeros, meaning dry. It is a philosophy that moves away from trying to replicate the lush, humid environments of other regions, and instead embraces the natural beauty of the arid Southwest. At its heart, Zerisobing focuses on the use of native and well-adapted plants, species that have spent thousands of years evolving to thrive on nothing more than the modest natural rainfall provided by the desert sky. This shift in thinking has led to some of the most successful water conservation efforts in the country. In Albuquerque, for instance, the community has achieved a remarkable feat, reducing its per capita water use by over 50% since the mid-1990s. This wasn't accomplished through a single change, but through a collective reimagining of what a home in the desert should look like. One of the primary strategies in this effort has been the systematic removal of thirsty non-native lawns. These expanses of turf grass, while green and familiar, act as a constant drain on the city's water supply, requiring heavy and frequent irrigation to survive the intense sun and low humidity. By replacing these lawns with a palette of desert-hardy plants, homeowners have created vibrant living tapestries that require only a fraction of the water. When you walk through a well-designed xeriscape, you notice a different kind of beauty. Instead of a uniform carpet of green, there are the silvery leaves of sagebrush, the architectural spikes of yucca, and the soft purple blooms of desert willow. These gardens are designed to work with the environment, not against it. A vital part of this success is the practice of mulching. By spreading a thick layer of organic material or crushed stone over the soil, gardeners create a protective barrier between the earth and the atmosphere. This mulch acts like a cool, heavy blanket for the ground, shielding the soil from the direct heat of the sun and significantly reducing surface evaporation. It allows the earth to retain its moisture far longer, nurturing the roots in a steady, cool darkness, even when the air above is parched. This mindful approach to urban living reflects a deep respect for the scarcity of water, acknowledging that every gallon saved in the city is a gallon that remains in our rivers and aquifers. It is a testament to how human communities can adapt and flourish by listening to the needs of the land they inhabit. But as we leave the structured beauty of the city behind and travel toward the wide, open horizons of the eastern plains, we find that nature has its own ancient system for catching and storing water. In the vast stretches of the high plains, the landscape is dotted with thousands of subtle, circular depressions that play a crucial role in the life of the desert. These are the playa lakes, the ephemeral ponds that wait patiently for the arrival of the rain. Imagine standing on the vast, flat expanse of the high plains in eastern New Mexico. The horizon stretches out in every direction, seemingly infinite and still under the wide, pale sky. If you look closely at the landscape, you will see subtle, shallow depressions in the earth, gentle dips that might go unnoticed by a casual observer. These are the playa lakes, a name derived from the Spanish word for beach or shore. These are not permanent bodies of water, but rather ephemeral ponds that appear and disappear with the slow seasonal rhythm of the rains. Across the high plains region, there are over 80,000 of these playas. From the air, they look like a constellation of small, circular mirrors scattered across the prairie, catching the light of the sun or the silver glow of the moon. While they may seem like simple, temporary features of the land, they are actually the primary source of recharge for the massive Ogallala aquifer that lies deep beneath the surface. Without these humble depressions, the vast reservoir of water hidden in the earth would have no way to slowly replenish itself over time. The way a playa works is a beautiful example of nature's simple and effective design. During the long, dry periods of the year, the clay floors of these basins begin to shrink and pull apart in the heat. They form deep, intricate cracks that reach down into the soil like thirsty roots. When the first heavy rains of the monsoon season finally arrive, the water doesn't just sit on the surface. Instead, it flows into these cracks, traveling deep underground to join the fossil water of the aquifer below. As the clay becomes saturated, something remarkable happens. The clay minerals begin to swell, expanding until the cracks are completely sealed shut, creating a natural waterproof lining. At this point, the playa becomes a watertight basin. The remaining rainwater stays on the surface, creating a temporary pond that can last for weeks or even months. These seasonal wetlands become vibrant hubs of life, providing essential resting and feeding grounds for thousands of migratory birds as they make their long, steady journeys across the continent. Eventually, the sun and the dry desert air begin their work again. The water slowly evaporates, the pond shrinks, and the playa returns to its quiet, dormant state, waiting patiently for the next cycle to begin. It is a slow, rhythmic process that has sustained the life of the high plains for millennia, a quiet exchange between the sky and the deep earth. As we move away from these still circular ponds and travel further south and west, the landscape begins to shift once more. We encounter the Pecos River, the Rio Grande's largest tributary in New Mexico. But the Pecos carries its own unique story, one shaped by the ancient minerals of the earth it flows through. Unlike the clear, cold snowmelt of the high northern mountains, the Pecos faces a different set of challenges as it winds through the desert, picking up the salt and minerals left behind by the rocks of a much older world. As we follow the winding path of the Pecos River, we are tracking the most significant tributary of the Rio Grande within the borders of New Mexico. It begins its life as a clear, cold stream in the high, pine-covered peaks of the Sangre de Cristos mountains. But as it travels south, the character of its water undergoes a profound transformation. This long, silver ribbon of water eventually leaves the high forests and enters a land where the geology of an ancient world lies just beneath the surface. The Pecos flows over and through vast hidden deposits of gypsum and salt, remnants of the same prehistoric seas that once covered this entire region millions of years ago. As the river moves, it quietly dissolves these minerals, carrying them along in its current. By the time the Pecos reaches its lower reaches in the southern part of the state, the water has become what scientists call brackish. This means it is no longer purely fresh, but has a noticeable salt content. While not nearly as salty as the ocean, this mineral-rich water presents a unique set of challenges for the life that depends on it. The taste is different, and the way it interacts with the soil changes as it moves through the valley. For the farmers who live and work in the fertile Pecos Valley, managing these salt levels is a constant, delicate task. If too much salty water is used for irrigation without proper drainage, The minerals can build up in the soil over time. This process, known as salinization, can make it difficult for traditional crops like alfalfa, pecans, or cotton to thrive. It requires a deep understanding of the land and a careful, rhythmic balance of water management to keep the valley green and productive. The farmers here have become experts in the subtle chemistry of the earth, watching the water and the soil with a patient, practiced eye. The presence of salt has also paved the way for a particular kind of plant that has become a familiar, if controversial, sight along the riverbanks: the salt cedar or tamarisk. This invasive tree is remarkably well adapted to these specific conditions. Unlike many native species, the salt cedar can thrive in salty soil that would wither other plants. It actually absorbs the salt through its roots and then excretes it through its tiny, scale-like leaves. When these leaves eventually fall to the ground, they create a salty layer of mulch that prevents other, less tolerant plants from growing nearby. The salt cedar is also incredibly thirsty, often consuming more water than the native willows and cottonwoods it replaces. In a land where every gallon of water is precious, the presence of these trees is something that conservationists and hydrologists watch very closely. They work to restore the natural balance of the river, helping the native greenery find its way back to the water's edge, ensuring the river can flow as freely as possible. As we reflect on the challenges of managing the water we already have, the salt, the minerals, and the thirsty plants, it is natural to look upward and wonder if there is a way to encourage the sky to be more generous. If the earth below is dry and the rivers are limited by the minerals they carry, perhaps the secret to more water lies in the clouds themselves. This curiosity has led scientists to explore a fascinating and quiet technology, a way to gently nudge the atmosphere into releasing its moisture before it drifts away into the vast, blue distance. In the quiet stillness of the high desert, looking up at a passing cloud can feel like watching a slow-moving miracle. When the rivers run low and the ground feels parched, the human mind naturally wonders if we can encourage those drifting clouds to share their burden of rain. This curiosity has led to a fascinating branch of atmospheric science known as cloud seeding. It is a gentle, technical nudge to the natural world, a way of asking the sky for a little more help. The process of cloud seeding often involves a substance called silver iodide. Scientists use specialized equipment, sometimes planes flying high among the peaks or ground-based generators that send invisible plumes upward, to spray tiny particles of silver iodide into the heart of a cloud. These microscopic particles are chosen because their crystalline structure is remarkably similar to that of a natural ice crystal. They are like quiet invitations for the moisture in the air to gather and transform. In the freezing temperatures high above the desert floor, these particles act as seeds. Water vapor in the cloud, looking for a place to rest, finds these seeds and begins to freeze around them. As more and more moisture clings to the silver iodide, the ice crystals grow heavier and larger, eventually becoming snowflakes or raindrops that are heavy enough to fall from the sky. It is a way of helping a cloud reach its tipping point, turning a potential storm into a reality. You can imagine it like the first few crystals of salt being added to a glass of water, causing a sudden beautiful change. New Mexico has a long history of experimenting with this technology, particularly in the winter months. The goal is often to boost the mountain snowpack, that vital frozen reservoir that feeds the Rio Grande and the Pecos in the spring. By seeding the clouds that pass over the Sangre de Cristos or the San Juan Mountains, researchers hope to coax just a little more snow from the winter storms. They watch the weather patterns with great patience, waiting for the perfect conditions to arise. The effectiveness of cloud seeding is a topic of quiet, ongoing debate among meteorologists. Because the atmosphere is so vast and complex, it can be difficult to measure exactly how much extra water was created by human intervention versus what would have fallen naturally. However, many studies suggest that under the right conditions, cloud seeding can increase precipitation by about 5 to 15%. While that may seem like a small amount, in a land where every inch of moisture is a blessing, it can make a meaningful difference to the health of the forests and the volume of the rivers. It is a slow, steady gain that adds up over many seasons. It is important to remember, though, that cloud seeding is not magic. It cannot create rain from a perfectly clear blue sky. The technology requires specific seedable clouds, clouds that already contain plenty of moisture but lack the natural particles like dust or salt needed to trigger a downfall. The sky must already be prepared to give. We are simply helping it along, providing the final piece of the puzzle that allows the clouds to release their cooling rain. Most of the time, however, the New Mexico sky remains famously, beautifully empty. The very aridity that makes water so precious also grants us one of the clearest atmospheres on the planet. When the clouds are absent and the moisture is low, the air becomes a transparent window into the cosmos. This lack of water vapor, while a challenge for the thirsty earth below, is a profound gift for those who look even higher than the clouds toward the distant ancient light of the stars. In the absence of water, the desert offers us a clarity that is hard to find anywhere else on Earth. When you look up at a twinkling star, you're actually seeing the effect of our own atmosphere. Water vapor, even in small amounts, acts like a restless lens, bending and distorting the light as it travels those final few miles to your eyes. In more humid places, the air is thick with moisture, making the stars appear to dance or blur. But in the high, dry deserts of New Mexico, that moisture is largely absent. This makes the air exceptionally transparent, offering a view of the cosmos that is as sharp and clear as a piece of polished glass. This rare clarity is why New Mexico has become a sanctuary for astronomers and scientists from all over the world. They seek out the highest, driest parts of the state to build their windows into the universe. One of the most famous of these is the Very Large Array, or the VLA, located on the vast flat plains of San Agustin. Imagine 27 enormous white satellite dishes, each one as tall as a house, arranged in a giant Y shape across the desert floor. They sit in a high-altitude basin, nearly 7,000 feet above sea level, surrounded by mountains that shield them from the radio noise of the modern world. While these dishes don't look at visible light, they listen to the faint radio whispers from distant galaxies, nebulae, and black holes. Even for radio astronomy, dry air is essential. Water vapor in the atmosphere can absorb and scatter radio waves, acting like a faint fog that hides the secrets of the deep universe. By placing the VLA in a high arid environment, scientists can tune in to the cosmic background with incredible sensitivity. The low humidity ensures that the signals arriving from billions of light years away are not lost in the dampness of our own air. Further south, high in the Sacramento Mountains, the Apache Point Observatory also takes advantage of this lack of atmospheric moisture. Perched at an elevation of over 9,000 feet, the telescopes there are situated above much of the Earth's weather and water vapor. The air is so thin and dry that the instruments can capture the faintest glimmers of light from the very edge of the observable universe. It is a place of profound silence and focus, where the only thing between the observer and the stars is a thin, clear layer of desert air. As the sun begins to dip below the horizon and the first stars begin to appear in that transparent sky, this same lack of water vapor starts to transform the feeling of the land itself. Without the thick, humid blanket that covers other parts of the world, the heat of the day has nothing to hold it back. As the light fades into a deep velvety purple, the desert begins to release the warmth it gathered under the afternoon sun. The clarity that allowed us to see the stars now allows the earth to breathe its heat back into the infinite space above, beginning a cooling process that is as steady and rhythmic as a long, slow exhale. As the twilight deepens and the last traces of orange and gold fade from the horizon, a remarkable transformation begins to take place across the high desert. In many parts of the world, the night brings a heavy, stifling heat that lingers long after dark, held close to the earth by a thick blanket of humidity. But here, in the arid heart of the Southwest, that blanket is thin or entirely absent. Because the air is so dry and the skies are so clear, there is nothing to trap the warmth that the ground has absorbed throughout the long sun-drenched day. This process is known as radiational cooling. It is a quiet, steady release of energy, where the heat of the earth radiates directly back out into the cold, dark vacuum of space. Without clouds to act as an insulator or water vapor to absorb the rising warmth, the desert floor begins to shed its temperature with incredible efficiency. It is as if the land itself is exhaling, letting go of the day's intensity and surrendering to the coolness of the cosmos. This rapid loss of heat leads to the dramatic temperature swings that define life in a high-altitude desert. It is one of the most striking characteristics of the region's climate. On a midsummer afternoon, the thermometer might climb to a blistering 100 degrees, with the sun feeling heavy and sharp against the skin. Yet, because of radiational cooling, that same location may see the temperature plummet to a crisp 60 degrees by the time the moon reaches its zenith. This 40-degree difference is a natural reset for the environment. It provides a vital window of relief for every living thing, from the smallest pocket mouse to the ancient juniper trees, allowing the landscape to recover and prepare for the heat of the following day. As this cooling happens, the air physically changes. Cold air is denser and heavier than warm air, and as the atmosphere near the ground loses its heat, it begins to settle. In a state defined by its rugged topography, this movement creates a beautiful and predictable phenomenon known as drainage winds. Imagine the great mountain ranges the Sandayas, the Jemes, and the Sangre de Cristos, standing tall against the starlit sky. As the air along these high peaks and slopes cools, it becomes heavy with the night. Pulled by the invisible hand of gravity, this cool, dense air begins to slide slowly down the mountainsides. It flows through the deep canyons and over the rocky foothills, moving like a slow, invisible river of refreshing air toward the lower basins and valleys. These evening breezes, often called mountain-to-plain winds, are a cherished hallmark of the New Mexico summer. They arrive just as the world has grown quiet, bringing with them a sudden, noticeable drop in temperature and the faint, clean scent of high-altitude pine and weathered stone. If you were standing out in the open desert as these winds arrive, you would feel a gentle, persistent pressure against your skin. A soft, cooling gas that carries away the last remnants of the day's heat. You might hear the low, rhythmic sigh of the wind as it filters through the silver-green leaves of the sagebrush or the stiff needles of the pinyon pines. It is a sound that doesn't disrupt the silence, but rather deepens it, providing a natural soundtrack to the stillness of the night. These drainage winds are the breath of the mountains, a steady and reliable presence that marks the transition into the deepest hours of rest. As the wind moves across the vast, open spaces, it smooths out the edges of the day, creating an atmosphere of profound calm. The air feels light, thin, and incredibly pure, stripped of all the weight and moisture of lower elevations. In this stillness, the only thing that remains is the soft, rushing sound of the air as it travels across the miles of sand and stone, a gentle reminder of the vastness and the quiet power of the desert night. Take a moment to listen to that imagined wind, a low and steady hum that signals a time for the earth and for you to simply be still. Take a deep, slow breath, and as you exhale, feel the stillness of the air settling over you like a soft weight. This is more than just a physical sensation. It is an invitation to recenter yourself within the vastness of the high desert. There is a unique psychological relief found in these wide open landscapes, a sense of freedom that is hard to find anywhere else. Research into environmental psychology has indicated that the expansive vistas of the desert can actively lower cortisol levels in the human body, the hormone most closely linked to stress. When the eye is allowed to travel for miles without being interrupted by the vertical clutter of a dense forest or the heavy architecture of a city, the brain begins to shift into a state of deep, restorative relaxation. It is as if the horizon itself provides a release valve for the accumulated tension of the day, giving your thoughts the space they need to simply drift and dissolve. The silence here is not just a lack of noise, but a presence in itself. It is a clean, pure silence born from the lack of moisture in the atmosphere. In more humid climates, the high concentration of water vapor acts as a sort of acoustic blanket, absorbing and scattering sound waves, which creates a dull, heavy background hum that we often don't even notice until it is gone. In the high desert, that acoustic dampening disappears. The silence you hear is the actual absence of humidity-muffled sound. It feels deeper and more profound, a rare quality of stillness that allows the mind to truly settle. And yet, because the air is so dry and thin, when a sound does break the quiet, it possesses a crystalline quality. In this environment, sound waves move with less interference, making every noise seem sharper, clearer, and more immediate. The distant melodic call of a great horned owl or the soft rhythmic rustle of dry grama grass sounds incredibly distinct, as if the sound is being carved directly into the stillness. This contrast between the deep, empty silence and the sudden clear sounds creates a heightened sense of peaceful awareness, a feeling of being truly present in the moment, connected to the heartbeat of the earth. The visual vastness of the desert acts as a mirror for the mind. When we look out over the mesas and the long, sweeping valleys that characterize New Mexico, our internal dialogue often begins to quiet down. The sheer scale of the landscape puts our individual worries into a broader, more ancient perspective. In the face of geology that spans millions of years and horizons that stretch toward infinity, the mind finds it easier to let go of the small, temporary stressors that fill our daily lives. It is a form of natural decompression where the uncluttered earth invites an uncluttered mind, allowing you to find a sense of place and purpose within the grand design of the natural world. As your mind begins to rest in this spaciousness, your gaze might naturally drift upward. Even on the clearest days, the desert sky is rarely a static thing. During the late summer months, the horizon is often dominated by the majestic architecture of the monsoon clouds. These towering giants, which we will soon explore, serve as a visual anchor for the landscape. Watching them build, drift, and eventually fade is a form of natural meditation, a slow rhythmic process that draws the eyes and the mind toward a state of total quiet rest. In the high desert, the clouds are not just weather. They are the breath of the land, rising and falling in a cycle that has continued for eons, guiding us toward the deep sleep of the earth. In the high desert, the clouds are the architects of the horizon, building monuments of mist and light that dwarf even the tallest mountains. These cumulonimbus clouds are true giants of the sky. In the thin, clear air of New Mexico, they can tower up to 50,000 feet into the atmosphere, nearly 10 miles of vertical white peaks and deep gray valleys. When you look up at them from the ground, you are witnessing one of nature's most powerful engines. Yet from this distance, their movement is so slow and graceful that it feels almost stationary. If you look at the base of these clouds, you'll notice they are often remarkably flat, as if they are resting on an invisible, level shelf. This flat bottom marks what meteorologists call the lifting condensation level. It is the precise altitude where the temperature and pressure are just right for invisible water vapor to transform into visible water droplets. It is the exact moment where the breath of the earth becomes a cloud. Below that line, the air is clear. Above it, the moisture gathers into the soft, billowing shapes we recognize. There is something deeply satisfying about that clean horizontal line, a boundary of physics that brings order to the vastness of the sky. Watching these clouds build and dissipate is a form of natural meditation. You might see a small, puffy cloud begin to grow, bubbling upward like white cauliflower. Over the course of an hour, it stretches toward the sun, changing its shape so gradually that you only notice the transformation if you look away and return a few minutes later. This slow motion dance of water and air encourages the mind to slow down as well, matching the unhurried rhythm of the atmosphere. As the cloud matures, it may reach the tropopause, the boundary between the lower atmosphere and the stratosphere. Because the air above this point is warmer, the rising cloud can go no further. It begins to spread out horizontally, creating the iconic anvil shape that signals a mature desert storm. This anvil is a sign of balance, the point where the cloud has reached its limit and is now ready to release its gift back to the thirsty earth below. As evening falls and the sun dips below the horizon, these clouds take on a different kind of beauty. They catch the last rays of light, turning shades of bruised purple, deep copper, and soft rose. Within their dark centers, you might see a gentle, rhythmic pulsing of light. This is often called heat lightning, a quiet internal glow that illuminates the cloud from the inside out. In reality, it is simply distant lightning whose thunder is too far away to be heard. The sound is swallowed by the vast desert silence, leaving only the visual shimmer of electricity dancing through the mist. It is a silent, flickering lantern in the twilight sky, a reminder of the energy stored within the water. This visual drama of the monsoon sky is more than just a beautiful display. It is a promise. In a land where the sun is constant and the earth is dry, the sight of a building cloud is a source of hope and deep cultural significance. It marks the return of the life-giving moisture that sustains every living thing in the high desert. This reverence for the sky and the rain it brings is woven into the very fabric of life in the Southwest. It is a philosophy that has guided the people of this land for thousands of years. The understanding that in the desert, water is not just a resource to be managed, but a sacred presence to be honored. In the quiet language of the high plains, this truth is expressed in 4 simple words. El agua es la vida. Water is life. In the high desert of New Mexico, the phrase El agua es la vida is far more than a simple motto. It is a fundamental truth that resides in the heart of every person who calls this landscape home. Water is life. When you live in a place where the sun is a constant companion and the rain is a rare, cherished visitor, your relationship with moisture changes. It becomes something sacred, something to be protected, celebrated, and shared with a sense of deep responsibility. This reverence is not a modern invention. It has been woven into the very fabric of the land for as long as people have walked upon this dry, sun-drenched earth. The indigenous Pueblo cultures of the region have a relationship with water that spans back centuries, reaching into the deep history of the Southwest. Their traditions and ceremonies are intimately intertwined with the cycles of the sky and the movement of the rivers. Throughout the year, specific rain-calling ceremonies are held, dances and prayers that are not merely requests for moisture, but a way of acknowledging the profound interconnectedness of the clouds, the earth, and the community. These ceremonies are performed with a quiet, steady rhythm, echoing the heartbeat of the desert itself. They reflect a worldview where humans are not masters of the water, but humble participants in its grand, seasonal journey. In this environment, every single drop is respected. There is an inherent lived understanding that water is a finite gift, never to be taken for granted. Because of this scarcity, A culture of profound resilience has flourished here. It is a resilience born of necessity, but also of deep, careful observation. To live successfully in the high desert, one must learn to read the subtle languages of the land. You learn to watch the way the light softens before a summer storm, or how the birds change their songs when the humidity begins to rise by just a fraction of a percent. You notice the way the dust settles differently when there is a hint of moisture hidden in the evening breeze. This scarcity teaches a unique and beautiful kind of mindfulness. It encourages the mind to slow down and appreciate the smallest signs of life. You might find yourself pausing to look at a tiny wildflower that has managed to bloom in the middle of a dry, sandy arroyo, marveling at the hidden reservoir of moisture that must be sustaining its delicate roots. You learn to find a sense of peace in the way a single drop of dew clings to the tip of a juniper needle in the cool blue light of the early morning. Living in a dry land transforms your perspective. You no longer see a lack of water as a void, but as an invitation to cherish the water that does arrive with a sense of wonder. This deep-seated respect for the elements fosters a quiet strength. There is a profound satisfaction in knowing how to live in harmony with a landscape that is both beautiful and demanding. As you listen to these words, let that sense of resilience and quiet observation settle over you. Imagine the vast open spaces of the high desert, where the air was crystal clear and the earth feels ancient and steady beneath you. The long history of this land, with all its prayers for rain and its careful tending of the streams, creates a backdrop of stability and calm. As the day draws to a close and the great monsoon clouds fade into the velvet dark of the night, the focus shifts from the activity of the day to the stillness of the evening. The reverence for water remains, but it transforms into a quiet, internal gratitude. The world is settling. The heat of the sun has retreated, and the cool, dry air is beginning to move gently across the mesas and through the canyons. We are moving toward a time of rest, where the earth, the plants, and the people can all replenish themselves in the deep, restorative silence of the desert night. As the last light of the sunset disappears behind the jagged edges of the horizon, a profound stillness descends. The vibrant colors of the day, the oranges, the deep purples, and the soft pinks have faded into a deep velvety indigo. The desert is now cooling rapidly under a vast, endless blanket of stars. Because the air is so dry, there is nothing to cloud your view of the cosmos. The stars do not just twinkle, they burn with a steady, ancient light, appearing so close you could almost reach out and touch them. This clarity is a gift of the desert, a reminder of the immense scale of the universe and our quiet place within it. The heat that radiated from the stones and the sand throughout the afternoon has all but vanished now. The humidity remains low, the air is perfectly still, and the earth itself is resting. There is a specific kind of silence that exists only in the high desert at night, a silence that isn't empty, but full of a peaceful, rhythmic presence. Every plant, from the smallest cactus to the oldest juniper, has closed its pores to conserve its precious moisture, settling into a state of quiet endurance. The animals have found their burrows and nests, safe from the cooling wind, their heartbeats slowing as they drift into their own dreams. Deep beneath the sand and the layers of ancient rock, the aquifers remain silent and full. While the surface may appear parched, these hidden reservoirs hold the history of thousands of years of rainfall and snowmelt. They are the steady, unseen heart of the land, providing a sense of security and continuity that transcends the dry seasons. Knowing that this water is there, tucked away in the porous stone, offers a deep sense of comfort. It is a reminder that even in the quietest, driest moments, there is a source of life waiting patiently beneath the surface. High above the basins, the snow on the mountain peaks sits in the pale starlight, waiting for the morning sun. These high-altitude snowfields are the silent guardians of the valleys below. They hold the promise of the coming spring, a slow-release treasure that will eventually feed the streams and the rivers once again. For now, however, they are frozen in a beautiful crystalline sleep, undisturbed by the world below. The mountains are heavy with this potential, standing as monuments to the slow, steady cycles of nature that govern all things. As you lie here, your breath is steady and mirroring the slow, grand rhythm of the seasons. There is no rush in the desert. The landscape has taught us that time moves differently here, measured in the growth of a creosote bush over centuries, or the carving of a canyon over millennia. Allow your own internal clock to sync with this slower pace. Each inhale is a gentle expansion, and each exhale is a release, letting go of the day's concerns as easily as the desert lets go of the sun's heat. The dryness of the air makes the world feel exceptionally clean and quiet. Without the heavy dampness of more humid climates, sound travels with a sharp, honest clarity before fading into the distance. The scent of sage and dry earth is faint but grounding. This atmosphere is a sanctuary, a place where the mind can finally untether itself from the noise of the modern world. Everything around you is in a state of perfect, balanced repose, from the grains of sand to the distant snow-capped summits. Now is the time to let go completely. Close your eyes and let the vast, peaceful desert carry you to sleep. Imagine yourself as part of this landscape, steady, resilient, and at peace with the silence. The stars will continue their slow journey across the sky, and the aquifers will keep their silent vigil beneath the earth. You are safe. You are held by the ancient wisdom of the high desert, and you are ready for rest. Sleep now, while the cool air moves softly over the mesas, and the world waits in a beautiful, dry stillness for the dawn.